Now, here is something I have noticed in mathematics classrooms across this country, and it shows up so consistently that at this point, I think it's structural rather than individual. But of course, before we jump in, over to you, Josh.
It's time for Math Joke of the Day. Why was the mathematician late for work? Because he took the wrong bus. But I'm bunching.
Okay, I think that's one of my favorites. All right. Most math classrooms are answer rich and question poor. Not because teachers don't know better, but because answers, they feel productive. Answers feel efficient and they feel like teaching. And questions, especially the questions that sit in the air unanswered for a few uncomfortable seconds, can feel like nothing is happening. But something is happening, something that answers can never replicate. Welcome to Show Me the Math Receipts. I'm Asali Smith, founder of Number Navigators, and this is episode 7. Now, if you were with us on the last episode when we talked about psychological safety, I want you to hold that as a backdrop for everything we discussed today. Because questioning only works in rooms where students feel safe enough to answer honestly. Safety is the soil. Questions are the seeds. And today, we're going to talk about how to plant them well. So let me describe 2 classrooms, and I want you to think about which one sounds like yours. In the first one, the teacher asks a question, waits about 1 second, calls on the first hand that goes up, the student answers, the teacher confirms or corrects, and then we move on. That cycle repeats 40 times per lesson, 180 days per year. And what it produces is a classroom where thinking belongs to the fastest student, where the rest of the room learns just wait for the answer, for the confirmation, for the signal that it's safe to write something down. The teacher's voice is carrying the cognitive load while students ride along as passengers. Now, in the second classroom, the teacher poses a problem and waits long enough for the discomfort to settle into something more useful, then calls on a student who has not spoken yet. That student offers something partial. The teacher doesn't confirm, doesn't correct. Instead, they ask, "What made you think of that?" Another student builds on it. Does anybody see anything different or see it differently? The room is in conversation with each other, with the mathematics, with the ideas themselves. That second classroom? Oh, it's noisier. Sometimes it's even harder to manage in real time, and it's producing something that the first one almost never produces. Students who are actually thinking mathematically, out loud, together, in ways that build understanding that lasts. The research here is deep and consistent, and I want to walk you through the pieces that matter the most. We talked about Mary Bud Rowe's work on wait time, and we found that it showed the average teacher waits less than 1 second after asking a question before intervening. Less than 1 second. And when teachers extended that wait time to just 3 to 5 seconds, the quality and the complexity of student responses increased dramatically. More students participated, responses became more elaborate, and students began asking their own questions. Teacher questions improved too, because the silence gave teachers time to think about what they were going to ask rather than just reacting or just moving to the next thing. And so wait time is not passive. It's one of the most active instructional decisions a teacher can make. And most teachers, They're not making it. Then there's the research of Magdalene Lampert and Deborah Ball from the University of Michigan, who spent years documenting what happens when teachers shift from what researchers call the IRE patterns, initiate, respond, evaluate, to genuine mathematical discourse. IRE is what the first classroom kind of looks like. Teacher asks, student responds, teacher evaluates. Efficient, familiar, and it concentrates mathematical authority entirely in the hands of the teacher. What Lampert and Ball found in classrooms that used genuine discourse was that students developed what researchers call mathematical agency, the belief that their own thinking is a valid tool for navigating mathematical difficulty, and that their ideas matter, that they can evaluate mathematical claims rather than just receive them. And mathematical agency is one of the most powerful predictors of long-term mathematical success, built almost exclusively through questioning, through classrooms that ask students to think rather than telling them what to think. Let me make this real because I want you to be able to hear the difference, not just understand abstractly. So a student is working on equivalent fractions. They look up and say, I don't know what to do. In the answer-led version, the teacher says, remember, whatever you do to the numerator, you do to the denominator. So if the numerator goes from 2 to 6, what did we do to it? And the student says, multiplied by 3? And the teacher says, right, so do the same thing to the denominator. The student writes the answer, moves on, and that interaction took about 45 seconds, if that. The student got the correct answer, but they learned nothing because the teacher did all of the thinking and the student executed the final step of a process that was already navigated for them. In the question-led version, the teacher could ask questions like, so what do you know about these two fractions so far? The student could say, well, they have different denominators. The teacher can say, well, what else? The student can look more closely. Oh, the numerators are different too. So the teacher can say, well, what's the relationship between 2 and 6? Student thinks about it. And they can say 6 is 3 times 2. The teacher now can say, well, does that relationship mean anything to you in this problem? And the student could pause, take some time to think about it. They look at the denominator. They might even try something and they get it. Not because the teacher told them, but because the teacher's questions pointed their own thinking in a productive direction. Now that may have taken 90 seconds, 45 seconds longer. And what that student built in those 90 seconds will outlast anything the first version could produce because they did the thinking. The teacher just asked the questions that made the thinking possible. Now, if you're a classroom teacher, one reframe that might be the most practically useful thing I say in this entire episode, the next time a student asks you a question, before you answer it, ask yourself, is there a question I could ask that could help the student find the answer for themselves? Not always. Like there are moments when a direct answer is exactly what's needed. But ask yourself, make it a habit, because the habit of reflecting thinking back to the student before you take it over is the single most accessible entry point into question-led teaching. You can start tomorrow in any lesson with any student. Now, if you're a math coach, questioning is one of the most observable skills in a teacher's repertoire. Sit in a classroom with a simple tally. Every time the teacher gives a direct answer, mark one column. And every time the teacher asks a question, mark another. And at the end of the lesson, share that with the teacher. And you can say something like, here's what I noticed about the ratio of questions to answers. Tell me what you see. And that conversation, grounded in evidence and open with genuine curiosity, is exactly the kind of coaching that changes practice without threatening identity. And if you are an instructional leader, when you walk into a math classroom, listen for questions, and specifically for what kind. Closed questions, expecting a single correct response, they tell you one thing. Open questions, inviting genuine thinking, tell you something else. The quality of the questions in a math classroom is one of the most reliable indicators of the quality of instruction. Name it, develop it, and celebrate it when you see it. Your Wednesday morning receipts. 2 things this week. First, count your questions. For one lesson, just one, tally every time you give a direct answer versus every time you respond with a question. Don't change anything yet, just count it. The data that you collect will be more motivating than anything I can say to you right now. Awareness always comes before change, and the numbers will tell you exactly where you're starting from. Now, the second thing, build a question bank, a physical one or a digital list of go-to questions that you can reach for in any mathematical moment. Start with these, okay? Make them your own if you have to. What did you notice? What have you tried? Can you say more about that? What would happen if the numbers were different? Does that always work? Or just sometimes? How do you know? Just to name a few. Now, those questions will carry you through almost any mathematical conversation. Post them where you can see them when you're planning, reach for them in the moment, and then watch what happens when you use them instead of the answer. So here's what I keep coming back to after years of watching this play out. The teachers who ask the best questions are not necessarily the ones who know the most mathematics. Can I say that again? The teachers who ask the best questions aren't necessarily the ones who know the most mathematics. They're the ones who have learned to trust that students' thinking is worth the time it takes to draw it out. That belief is what changes a classroom from a place where students receive mathematics to a place where they build it. And what that means is the question is never just a question. It's a signal, and it says, I'm here to think with you, not for you. And students, over time, will start to believe it. Next time, we're taking everything we've built across these first 7 episodes and watching it come alive in one of the most powerful instructional moments in mathematics education. What happens when students bring multiple strategies to the same problem, and why that moment, when it's facilitated well, is where the deepest mathematical thinking lives. You are not going to want to miss episode 8. My name is Asali Smith, founder of Number Navigators. This is Show Me the Math Receipts, and until next time, teach boldly, protect student thinking, and always keep your math receipts.